Hello and welcome to this beginner-friendly tutorial on Utility Intelligence, a powerful AI framework for Unity. In this tutorial, I'll guide you through setting up a simple AI system using Utility Intelligence, including patrol, chase, low health behavior, and refilling health. But before we dive in, it's important to understand that Utility Intelligence is not an out-of-the-box AI solution. Unlike plug-and-play AI assets, this framework requires some scripting knowledge. However, this also makes it highly flexible, allowing you to create advanced AI behaviors tailored to your game. So, let's get started. Before we start setting up AI behavior, let's go over some key concepts in Utility Intelligence. Utility World. This is the container that manages decision-making for all utility agents and entities. It ensures that decisions are calculated and executed properly within a defined environment. Utility Entity. Any game object that needs to interact with utility AI must be a utility entity. This could be an AI character, a player, or even an object like a health station. Utility Intelligence. This is the core system that grants intelligence to utility agents by helping them evaluate and execute the best decision based on their given considerations. Understanding the Utility Intelligence Editor tabs. Decision tab. This is where you create and manage AI decisions. Target Filter tab. This tab helps filter valid targets for decisions. For example, you can filter enemies or health stations. Consideration tab. Define how different factors influence decision-making, such as health level or enemy distance. Input. Normalization tab. Converts raw input values into a normalized range, 0 to 1, for better decision evaluation. Input tab contains the input sources that feed information into considerations. Blackboard tab stores shared data between AI components to improve decision consistency. Score curve defines how consideration scores influence decision-making. For instance, an inverse curve can make low health more critical in decision-making. To learn Utility Intelligence more intuitively, I highly recommend going through the demo scene files. Exploring the existing components and functions will give you a deeper understanding of how they work together. This hands-on approach is how I learned it myself, and it can help you grasp the concepts much faster. Additionally, Utility Intelligence comes with well-written online and offline documentation that you should reference as you build your AI. If you have questions or want to connect with other users and the developer, there is also an active Discord channel where you can engage with the community. Now that we understand these key components, let's proceed with setting up Utility Intelligence. Here we have a simple scene. We have a floor with a NavMesh surface component on it. We have a cylinder with the tag enemy, as this will be out test object for the enemy. Finally, we have our NPC character. I use a spider robot from a Unity asset called Protofactor. On this NPC, I set up a very simple one, D-blend tree animation. I use the float parameter speed, and I use 3 motion clips, 1 idle, 1 walk, and 1 modified walk, which is used as run. I basically just increase the animation speed. Now again, to emphasize that there are different ways to go around this, I show you my way, which is just one approach. Same goes with the scripting, as I am no programmer, you know better how to optimize your scripts in game in general. Let's create an empty game object and rename it to world. On this world component, we create a child game object, which we call world register. On the world component, add a utility AI world controller component. On the World Register component, add a Utility Entity Register component. This component needs to have all you AIs and objects you want to interact with. For instance, player, NPCs goes into the agent slots, and game objects such as health stations goes in the entity slot. In the World Register component, drag the world component into the world slot. Now you are ready to register AI and world objects. Let's set up our SpiderBot AI. Add the core component Utility Agent Controller. As mentioned before, We will utilize some components already included in the assets, which is very brilliantly crafted by the developed Carlos. We add character health components. Then we add a nav mesh agent and a rigid body component. For movement, we add the character movement script. Feel free to create or use your own logics. As we have the main components on our NPC SpiderBot, we don't need the utility agent facade component. You can remove it. Now we need to create a utility intelligence scriptable, which basically is the whole framework of this asset. Do this by right-clicking from the project window, then create CarlosLab, and finally the utility intelligence asset. Drag this newly created asset into the Intelligence Asset slot on your NPC bot. Open the editor. I have docked my utility editor next to my console as seen here. The Utility Intelligence Editor framework window is where you build up your AI. It's divided into sections, or tabs if you will. Let's start with the blackboard. Personally, I like to work or start from right to left, as this will make sense as we build up the AI. Blackboard is used to share information between multiple components in an agent. It contains a list of variables, and you can write to these variables for any purpose. It already comes with some handy build and data types we can use. Think of the blackboard as, instead of hard coding a value, you can reference and use across AIs doing it this way. Let's add the animator, nav mesh, string for our speed parameter in the animator, and 2 floats for walk and run speed. Since we want to start with a patrol behavior, we also add a transform variable as we want a reference to our waypoints as a list. We will add the patrol script, which Carlos has provided us with later. Moving on to inputs. Inputs is used to calculate the score of a consideration. Again, it comes with a few pre-built inputs we can study and use or create our own. We will be using 2 for our example. We will be using a health input and a distance to target input. Give it a proper name, which I reuse for other name settings which are related. This gives us access to our health value. The health input is connected to the character health component. Keep that in mind as we are using the build-in input along with the build-in character health script. Let's inspect the input script. As you see, the health input class derives from input from source. It looks at the health value from character script. From character script, we see it has a public int health value, which it gets from character health script. Again, we are using the asset's own scripts, so most likely there are things you don't need. For instance, the character script contains teams and character energy parameters which you can delete or remove. But then again, these are more for you to study the examples and create your own. Input normalizations are used to normalize a giving value or a range. For instance, a health value can be any number, say 50%, 100%, or 350%. The normalize ensures to convert the data so it can be scored between 0 and 1. We use one of the build-ins to create a normalization for our health and our distance to target. For checking up against the health value, we use a divide by max value. Normalizant, as our health value is of type in, as we saw in the scripts before. As my health is selected on the right side, you have the exposed parameter you can type in or change a curve value. On the max value, we enter 100, as our NPC has a maximum health of 100. On the input dropdown, we select our health input we created earlier. For the distance, we use a eyes in range normalized float parameter. I enter 200 as maximum. You can use whatever value or hook it to a blackboard value. On the input dropdown, we select our distance to target input we created earlier. Consideration's best explanation from the asset documentation says, in utility intelligence, a consideration, also called axis, represents an aspect of the game world that influences the utility of a decision, and its score indicates how appealing the decision is based on that aspect. Create a name for the consideration. We create one called health is high, and we create one we call distance to enemy. For each of them, we select our previous created inputs and normalizations. Now for the response curve, to easy understand think of it as the health value is represented on the x-axis going from left to right, so 100% health is on the far right side, and the y-axis as the score between 0 to 1. By inverting the curve, we start with a score of 0, but as the health goes down, the scores increases towards 1. By the way, you can tweak the curves in runtime. Very useful for debugging. Target filters are used to filter targets for the current decision. The asset comes with a few ready-made filters for us. I want to have a filter where I can manually type in the tag name for any game object. Let's take a look at how a filter is set up, then I show my own custom script. A little tip, when creating any scripts that need to interact with Utility Intelligence Framework, then create the scripts from within the corresponding folders from the asset. This way you won't run into any namespace conflicts or such. As you from this example, the other team filter derives from target filter. My example, we use public string to expose it in the utility editor. With this filter, your NPC can have this tag set up into its decisions. From the dropdown, let's select our custom tag filter and gave it a name. Per default, it has already enemy as tag. You can just change this for your specific setup. We keep our as enemy. Decision and utility intelligence. Each decision consists of target filters to select valid targets, considerations to calculate decision scores, action tasks executed if chosen. Decisions are scored per target, filtering out invalid ones first. Considerations determine scores, which are then weighted. The highest scoring decision target pair is selected, and its tasks are executed in sequence or parallel. Let's create a decision and call it patrol. Now for our patrol, we keep the weight at 1. When dealing with many decisions, you can increase the weight on a decision in order to give it higher priority, which can help you avoid possible conflicts. While patrolling, we don't need any target filters, nor do we set any considerations for now. Scroll down to the Action tabs. Here we use some of the build-in types. From the drop-down, select and add Nav Mashagant Patrol. Then select also a Move to Target And lastly, a set float from the animator category. Now select so the patrol task is highlighted. This should expose the values on the right side. Now we really take advantage of Blackboard values. As you see, patrol has 3 parameters exposed. To activate and use Blackboard values, check the 3 boxes. This should now give access to Blackboard values we created earlier. For nav mesh, you select the nav mesh. For speed, you can select the walk speed, and for the waypoints, we select waypoints. Do the same for move to target task. For the set float, this is the one that will play our animations while being in this decision. So for the parameter input, you select our speed parameter, which is connected to our speed float value from the animator. Below action, we want to run things in parallel. Now in the main intelligence tab, create a decision called Patrol. This gives option on the right side under the decision maker. From drop down, select our patrol. Now drag the spider bot into the World Entity Register Agent slot. We utilize a patrol script which Carlos has provided for us. Feel free to create your own. Add the patrol script to your NPC. Expose 3 slots for waypoints. I created a game object and called it WP. I made 3 child empties which I use for my 3 waypoints. The naming in the Blackboard need to correspond to the value within the patrol script. Here is the patrol script. As you see, it's important that the Blackboard variable names waypoints is exactly the same as in our Blackboard. This script gives you an idea how to connect and hook into the framework through Blackboard variables. Now the time has come to test our setup at this point. Hit play, and what we expect to see is that our NPC now executes the patrol between 3 points. While he is doing that, we can in real time monitor the intelligence editor. Congratulations! You created a patrolling NPC. Now let's create another decision called low health. This should be the top priority above everything else. Our goal here is when health is below a sudden value, say 50%, then it should go to a health point to refill. In the Decision tab, create a new one called Low Health. Switch to the Targets tab. In the Target filters, use one that is pre-built for us. It is called Charge Station Filter. Give it a name. This filter has the option to either use a health or energy station. In the Consideration tab, create a low health consideration. In the Input normalization, select our health input. On the response curve, let's tweak it. Use an inverse curve. Set the X shift to 0.5, which equals 50%. On the slope, we don't want a soft transition, we want a hard change, so if the health goes below 50%, then the score will be 1 equal to true, and then we want to perform a move to target action, where he should go to a health point object. Back to Decision tab. On your low health decision, we increase the weight to 1.5, so this has highest priority above them all. Ensure Target's filer's HP is added. Under Consideration, add the low health consideration. Now in Actions, we add a set float and move to target task where we just like before in the patrol setup, we use Blackboard values. On the Main Intelligence tab, create a new decision under Patrol and name it Low Health. On the Decision Maker, add the created Low Health decision. Now let's add a Health Charges Station game object. We use the one from the asset as an example. Drag it into the scene. Now we need to add this to our World Register component so it can be recognized. Now if we test it out, our NPC will perform the patrol task. If we modify or lower his health below 50%, he should run towards the health station. Let's test it out. Now let's create a chase behavior. In the Blackboard tab, we create a float value which we want to use as our chase distance range. Let's name it Chase Radius. I give it a value of 15. In the Input Normalization, create a Eyes in Range Normalization Float parameter and call it Chase Radius or whatever that suits your needs. In the max value, select our Blackboard chase radius we created earlier. In the input, select Dist2 target. Create a consideration and call it something like enemy in chase radius. In the Input Normalization dropdown, select our chase radius. Leave the curve to linear. In the Decisions tab, create a new and call it Chase Enemy. In the Target filter, select Enemy Filter and add it. This will ensure it looks for our game object with the tag enemy. In the consideration, select our enemy in chase radius. In the actions, let's add a set float to for controlling our animation. Use the Blackboard parameters. Finally, add a move to target and use the Blackboard parameters here as well. This is what I think it's so time-saving and power of utilizing Blackboard. Set the actions to be executed in parallel. Now in the Main Intelligence tab, we create a new decision maker and call it Chase Enemy. In the Decision Maker tab, we add our Decision Chase Enemy. What's left now is to add our enemy game object to the World Register component so it can be recognized by the AI system. First, add a Utility Entity Controller to the enemy game object. drag the game object into the utility entity's slot. At this point now, we should have an AI that starts in patrol mode. While patrolling, if he detects an enemy with the target filter within a range of 15 unit, he will chase the enemy. If the enemy gets outside the 15 range, then AI will return to patrol mode. And in this situation, his health has the highest priority. If it gets below 50%, then he will retreat and move towards a health station. Let's test it out now. If you made it to the end, thank you and congratulations. This was only a very basic overview of the AI framework. As you can see, it's very powerful and scalable. Only your own creativity sets the limit. Later, I will create a more advanced use case. Please write in the comments if you would like to see more utility AI tutorials. Leave a like and a sub if you enjoy the content. Take care and see you at the next one.